All right. So, like VJ said, welcome. Tonight we're going to be talking about Reason. So, intro to Reason. If you're not familiar with Reason at all, if you're familiar with JavaScript, this will be great. No Reason knowledge needed as a prerequisite to be chatting. We're not going to go deep into the weeds. We're kind of stay high level, and we're going to stay high level, and we're going to just do kind of a flyover of what makes the language cool, why it's exciting, and and we're just going to kind of look a little bit at the syntax. So really quick, a little bit about me. You can't see the picture too well because of the lighting, but I'm a front-end engineer at AutoGravity. We are a startup down in Irvine area. So we're working to make like a digital car buying experience kind of end-to-end from the moment that you say, hey, I want to look for my next car, to the moment that you actually are signing the paperwork. That's kind of our vision and our goal right now. We're working a lot with React, Redux, a lot of your modern front-end web stack, and we are hiring. So if you are kind of in the market, if you are looking, please pull me aside and I'll get you the deets on getting set up with our HR and talent department. Benjamin J, that is my Twitter handle and my GitHub handle actually. So then those are the two that matter. So with that being said, we'll get a little bit further in, and here we go. So I want to start out, and because of the light, I don't know, maybe the lights off might be a little better because, yeah. Okay, we can see a little bit more here. So I want to start off this whole intro to Reason by just giving us painting a picture, right? Paradise, I guess. So when you start out a code base, a lot of times maybe you have a fresh project, it's your first time through something. It can feel like the code is like this, right? It can feel just perfect. You've beautifully abstracted everything. All of your code is perfectly dry. You have unit tests. Everything is perfect. And sooner or later, someone from product comes over and they say, hey, can you do this? And I need it by yesterday. And I don't care what it takes, like get it out the door. And so you skip the unit tests, and then design has some flow that you disagree with maybe, or doesn't quite fit into the architecture that you made. And so you sacrifice a little there. And over time, your code base starts looking a little less like this and starts looking more like this. This is, because of the contrast, we can see this is Kevin dropping a massive pot of chili on the floor in the office, and just really trying. He's stumbling through chili on the ground. It's just a complete mess. And sometimes your code base might feel more like this. I'm sure no one ever feels like they're wading through chili in a code base. Just hypothetical. So I guess that leads us to this question, right? So how do we keep our code base from becoming complex? How do we keep it in paradise and not in chili on the floor? And to that, there's a few ways. Testing, of course, if you keep automated tests up and running, this is going to help you to, keeping your tests up and running is going to encourage you to refactor. It's going to make sure you don't introduce new bugs into your code while you're making new things, right? Make sure you don't break past features while making brand new features. You will have to maintain your tests, but this is one of the big cases for testing, right? In addition, if you're doing some type of test-driven development or something like that, that will also force you to kind of be a user of your code before you actually make other people be users of your code. Lintering and formatting, of course, those are also going to help us keep our code base sort of maintainable by encouraging a standardized style across the whole code base. Linters, maybe more than formatters, are going to catch bugs, potential bugs. But this is another way that we can keep our code base less complex. Peer review. Lots of studies and stats have shown that peer review is one of the best ways to keep our code base from introducing bugs, because now we have people that know the code base well, kind of offering feedback saying, hey, this is going to give us problems later in the future. And so you can really curb a lot of maintainability problems here. this is also probably the best spot for mentorship, right, within teams from seniors to juniors. So, and lastly, types. And as we get into ReasonML, we're going to be talking a lot about types because it is a statically typed language. And so with that, I want to do a quick flyover of kind of just the types in JavaScript ecosystem, right? So we have, on the far side, we just have JavaScript, and there's no types, right? So you can pass an array, and you can pass a string, and there's no compiler error. What you'll see is, cannot set undefined of null or something, the classic undefined error, right? It cannot call property map of undefined with a massive stack trace, and now in JavaScript, we've just learned to deal with this. In the middle, we have our TypeScript and Flow, which if you're not familiar, these kind of add types on top of JavaScript. So they operate with just kind of a JavaScript syntax. It's the same language under the hood, and they just add a type syntax on top. So caveat with these is they're only as good as you make it, right? So with TypeScript and Flow, you do have to be very diligent to add types, but there's a very small learning curve because it's just JavaScript under the hood. And then lastly, in our typed JavaScript ecosystem, we have compiled to JavaScript languages. So if you've heard of Elm, it's another player in this space. And then as we get to it, Reason. Reason is a completely separate language that compiles into JavaScript as well as other things. So with that, really quick disclaimer, PSA, whatever you want to call it. Types aren't a substitute for tests or vice versa. So as I was kind of shopping this around to my coworkers, colleagues, etc., one of the most common things I heard was, well, if I have a crap load of unit tests, do I even need types, right? Like I can solve all my type errors with a bunch of unit tests and a bunch of integration tests. And that is true. The side thing is, though, that you're going to spend all your time writing these unit tests for every possible case. And you're going to make sure that this little unit of work works. And then if another developer passes in the wrong thing, it doesn't matter that your unit tests are there if you don't have integration tests. And so now you have to do a whole bunch of integration tests. And while that's great, you can also spend your time writing tests for your business logic. That being said, a lot of people in the typed language space feel like, hey, I have types. They're protecting me. So do I even need tests? And you still need tests. You still need to test your business logic. There's just no way around it. Types aren't going to tell you whether you made an addition error or added something to the front of a list instead of the back of the list. They're just going to make sure that you don't pass an array when you thought you were passing a string. So that being said, what is Reason, right? So this is sort of a little bullet point list of what Reason is. It's a syntax extension on top of the Ocaml programming language. And we'll get a little bit more into what Ocaml is in a bit, but Reason isn't a new language, right? It's just a syntax for an existing language. And because of that, we get to leverage this existing language, and we get to leverage all the tools that have been around in Ocaml. Second, Reason actually has the same creator as React. The same guy at Facebook that made React actually made the initial prototypes of React in a cousin language of Ocaml. And when they decided to open source it, they ported React into JavaScript so that people would adopt it, right? So that it would be easy to use, easy to adopt. And so you'll actually see a lot of the patterns that React made mainstream in Ocaml. And that's pretty cool. And so you'll actually, you'll see a lot of those similar patterns and a lot of those similar ideas that are in React and are popular because of React, just native to the Ocaml language. Lastly, it just uses a familiar syntax, right? So the Reason syntax, the team behind Reason really put a lot of love into making the syntax easy to adopt for JavaScript developers. So it feels very much like JavaScript, as we'll see later, and the workflows are identical, right? We use NPM and Yarn every day, and Reason, all of the packaging for Reason, all of the compilers, everything you need is on NPM, which is pretty sweet, is because we don't have to change anything about our workflow, and we can add it into our code base without having to add any extra steps. So Ocaml, battle hardened over 20 years, right? If Reason is a syntax extension on top of Ocaml, what does Ocaml have that's cool, right? So Ocaml is really old. It's for a programming language, at least. Like JavaScript is old too. So it's kind of been battle hardened over the last 20 years. There's a lot of people in the academic space that like Ocaml, and so a lot of the solutions that it gives us are very, very mature and very well fleshed out. And because of this, it doesn't have maybe some of the weirdness that JavaScript has, right? None of the weird like this stuff happening. There is no this in Ocaml. The operators aren't overloaded, so you can't add a number and a string together, and you don't end up with that weird scenario as well. Ocaml is immutable and functional by default, so it supports. It's primarily a functional language, right? So if you're into functional programming, this is cool. And most of the data structures in Ocaml are immutable by default. So this really supports not changing things on the fly and not just hacking all your state into some object and then keep updating it, and before you know it, things that you didn't expect are happening. That being said, also allows us to write mutable code, which this means we can actually ship things to production, right? Like if you've ever played with a truly pure functional language, it is a pain in the butt, right? Like not being able to do side effects, especially in front-end web development and the browser, is really, really hard. And so having the ability to write imperative code, write mutable code, lets us choose what actually is the best solution for the problem at hand. However, having the language encourage us into functional paradigms lets us kind of have this great default, and then we can break out of that when we need to. It has a good type system, and really good inference. If you've ever written TypeScript, you'll note that you have to type a lot of things, right? You have to write a lot of type code. And Ocaml does most of that for us, right? So the compiler will kind of infer most of the types without us having to write them. And that's pretty cool because it's less writing on our part, right? Lastly, it compiles to basically everything. Because it's been around for 20 years, the Ocaml compiler by default compiles down to assembly. So if you can write Reason, you're a native developer at that point. And there are lots of libraries and compilers in the existing Ocaml ecosystem that give us the ability to write iOS apps, Android apps, and as we'll see, web apps. So BuckleScript is the compiler that lets us write web apps, right? So this is a JavaScript meetup. We are talking about JavaScript, but we're also talking about Ocaml, right? And so what's the link between these two? And that is BuckleScript. So BuckleScript will do a lot under the hood because it is a different language. BuckleScript basically heavily optimizes the compiled output while still being sort of human readable, but it will compile our files inline as well. And so as we'll see later, it's pretty easy to integrate into an existing project one by one because you can just, it doesn't compile all of your stuff into one massive file, and then you have to figure out like where your files are. It compiles each file one for one. And that's pretty cool if we're trying to integrate Reason, Ocaml into a project incrementally, which in any real world code base, we don't get the chance to just kind of hard refresh and start writing from scratch. So incremental updates are the way to go. So this is my question, right? Is this all really necessary, right? Why? Like, this sounds like a big pain in the butt to add, right? For the promise of less runtime errors, the promise of type checking, all of this stuff. Is it really necessary? And to that, maybe necessary. Like people have been shipping JavaScript apps for a long time, and they've been shipping them to production without Reason. So it's not necessary, but is it good? Yes. Having those guarantees, having those guarantees that your program is not going to throw type errors, and that bugs aren't going to sneak into your code as easily, is really helpful. And while there is a learning curve to Reason, I definitely think it is worth it. So that leads us to our next slide, which basically says, you know, it might not be right yet. It might not be right for your company's app. It might be a hard sell right now because it is so new and it is so unfamiliar, but it is an up-and-comer. You know, kind of Facebook is supporting Reason, and so there's a lot of support for the language, and they're building a lot of things and moving fast. Facebook has been using it on messenger.com for the past couple of years now, and they actually, I remember hearing on a podcast that since Facebook moved most of their code base on Messenger to Reason, they actually have had basically 0 bugs committed to production by juniors and interns. Which is pretty cool that like people with very little experience can hop into the code base and not break things. So it's worth keeping your eye on. It's worth maybe doing a personal project, kind of doing some proof of concepts. If you're really, really daring, you know, convincing your company to go forward with that and live on the edge. But I would say right now, a lot of the people in the Reason community are early adopters, right? So keep your eye on it. Probably in the next year or two, we're going to start seeing a lot of traction happening in that community. So with that, that's kind of the ecosystem of Reason, right? So we have, it compiles to Ocaml, and then from Ocaml, it compiles to JavaScript. And it feels like JavaScript, but it's not JavaScript. So with that, I just want to do a quick flyover of the syntax, kind of see what we're looking at, see how does it feel so close to JavaScript, and what does it actually give us that's unique, right, from JavaScript. So let's look. So functions, right? This is what a function looks like in Reason. So we got add, first, second, first plus second, and we call it like that. If you're astute, you might notice this is valid JavaScript, right? We could take this and copy paste it into our JavaScript code, and it would work. So the base function syntax is very, very natural, right? One thing to note, though, is that these let bindings, there is only let in Reason for variable assignment. So you don't have this like let versus const versus var, and how does one work versus another, and there's slight differences, but you know, more or less they all do the same thing. In Reason, you just have let. And that is actually really nice to only have one variable assigning syntax. So, however, even though this function looks like JavaScript, it's not truly JavaScript under the hood. All of the functions in Redux, or sorry, not Redux, Reason, are automatically curried. So under the hood, this a comma b, right, and then a times b, actually, if we were to write it in JavaScript, it would look like this, right, where we would have a function starting with a, returning a function that takes b, returning the actual output of the function. And so what this gives us, this might feel unfamiliar if you're coming from JavaScript land, but this is actually very common in functional languages to do this. And the reason is that you can create kind of new functions as you go throughout your app. And as you have the data, you can add the data, and then you can kind of add more data, and then when you're actually ready to call, you can go ahead and call it. So like in this case, we can, from our multiply function, we can create a ×3 function that just assigns a, right? It just says a is 3, but that returns a new function that then we can call, and we would get 12 in this case. So I think that's pretty sweet. And it's just all under the hood for you. So you don't have to worry about a different syntax for currying. If you were to do this in JavaScript, you'd have to import a few libraries, right? You'd have to do something with like Ramda or Lodash, I believe, has a currying function, or you'd have to write all of your functions with this arrow syntax. So the other thing that Reason functions have, here, let me just bump this down so we can see at least this slide, is labeled arguments too, which is cool. Like that's this little tilde, right? It says that I want this argument to always be labeled, and I want it to always be called with that label. And so that gives us a little bit of documentation maybe about our functions. A lot of this is up to you, the developer, to say, hey, I want to do a regular function or a labeled function. But it does give us the ability to kind of say, like, we know exactly which one is being added to which one if we label them as text in addition. One more little thing to note really quick is that this ++ operator is the string concatenation in Reason. We don't have overloaded, like in JavaScript, you do everything with the plus operator, right? You add numbers, you add strings. I don't know what else we add in JavaScript, but we can add, a number plus a float, right? Like all these scenarios. And Reason, you don't actually have that. You just have pluses for integer addition and plus is for string addition. And so you don't end up with bugs like number plus a string, and now we actually had a bug like that happen in AutoGravity a few weeks back, where there was a number plus a string, and somehow it slipped into the code base and reared its ugly head months later. And you just don't have those type of bugs in a statically compiled language. So with that, moving on from functions, let's look at the record type in Reason. So records are the closest thing that we have to a JavaScript object in Reason. They do require a type definition. So a record requires us that we do say type animal. Oh, crap. Does require that we say type animal, and does require that we say it has maybe a rank and a species. But later, the actual type will be inferred. So if you've done any TypeScript or anything, to get the typing on your record, you have to declare it right here, right? And you have to say, like, dog is an animal. The compiler isn't going to pick that up on its own. You have to kind of say it yourself. Reason will pick that up. It'll say, hey, you added something with a rank and a species. I bet it's an animal. Great. However, sometimes that can be a little weird. Sometimes the compiler can pick up the wrong record, which is a little bit awkward. And so if you do want to do that, you can explicitly say, this is an animal, and it's ranked lower. Sorry if anyone's a cat person. I'm a dog person, so I rank dogs as 1, cats as 2.
Still pretty good for cats.
Yeah. I mean, I guess, yeah, probably like birds or something, maybe in between. So that was kind of our object syntax. This is our list and array syntax. So list is a data type that feels like an array, but it's not an array under the hood. This is actually compiled down to a link to list. And as such, it is an immutable data structure, right? So we can't go in and modify. If we were to do something like this, we're actually creating a new list. And then, if we were to pull items out, we'll be just pulling those items out and copying them into their own variables. So this is one of those, like I said, immutable first data structures that Reason has first-class support. The second one is arrays, right? And they are mutable. So they're closer to what we would think of like a JavaScript array, where you can reach in and you can change things. So we can say, we have our array that says my little array. The bracket plus the pipe syntax, that's to denote an array versus a list. And if we wanted to reach in and change it to say my little pony, it can say that. We've got that, and we can do that. They're mutable, but they are faster at going and reaching in the middle, right? If we have a linked list, it's a little harder to get to the end. So these are kind of the two data structures for list types, and they give us actually a lot of flexibility for how we work with data. One thing to note with this is that the array syntax does feel awkward, right? Just a little bit awkward. And this is one of those cases of Reason allowing you to do mutable code, but not encouraging it, right? So it makes the list syntax feel super, super clean, super, super neat. And the array syntax is just a little bit more awkward. It's kind of one of those just subconscious ways of saying, like, are you sure you want a mutable array? Are you really sure you want to do that to your app? But it still lets you do it, which some languages don't. Some of these functional compile languages like Elm won't let you do mutability at all. So it's cool that we can actually do these things to get our job done. So those were kind of the ones that are close to JavaScript, and now we're kind of going off into Reason land, where we start to feel this is a different language under the hood, right? So a variant type, we would say, let vehicle, I believe this should actually be type, sorry for the typo, but it basically says, hey, it has to be one of these 3 strings, essentially, right? Under the hood, this is compiled to like 0, 1, and 2. If you're familiar with TypeScript enums, this would be the closest thing in JavaScript and TypeScript land that we have to the variant type. However, it kind of ends there, right? With the enums, we can't pass arguments. And with the variant types, we can actually pass data along with our variant. So in this case, we can say let Toyota equal car, which was this type, and we can actually pass a string with it. And this, as we'll see in a little bit, gives us some pretty cool opportunities for passing data and guaranteeing that we match all of our various cases that we can use. So like I said, here's one of the cases of pattern matching maybe on a variant type. Pattern matching is kind of one of the crown jewels of the Reason syntax and the Ocaml ecosystem, because it lets you really handle a lot of cases in your app, and a lot of those cases where you might say like, hey, if I have this, I need to do this, and if I have this, then I need to do this. And you know, in JavaScript, you may do this with a switch case. You may do this with a whole bunch of if-else statements. Those are really the only two ways to do this. And so we have a switch, and each of these are our cases, right? As we saw earlier, we can pass data with it, so we can actually create a different experience for car that says like traveling in a plus the make on land. But for the other ones, we don't have the data, so we just return a string. And when we pass the car into the function with the make, we actually get the whole concatenated string, which is pretty cool and lets us kind of pass our data along. This is where we can see that this isn't just an enum under the hood. So, however, we can pattern match on more. So the earlier pattern matching feels like a switch case, right? Just all the way down. This isn't anything like a switch case. If you were to replicate this in JavaScript, you'd have a bunch of if-else statements. What this is doing is pattern matching on a list, right? So we say post is a list, and we can actually pattern match against all the various types of scenarios we could have with that list. So an empty list, we can return one thing, maybe a full list, right? But we only care about the first item, and we only care that it says intro to reason, right? So if we can actually add conditionals to our switch case. So in JavaScript, we'd have to say, if the type of post is a list, if it has a length, and if it has a first item, and if the first item is this, and you just have this massive conditional for that one branch, right? This would be matching on a list of only one item, and you'd say that's your only option. And this would be matching on a list of at least 2 items, but potentially more. And you just say like, hey, try the first or try the second. And so this is where, like I said, the Reason syntax really starts to shine and really lends itself to very elegant patterns in our code. So there's pipe syntax too, which is cool. Under the hood, it's just sugar for applying the function like this. So you just read it backwards, right? So it kind of saves you from parentheses hell, though, if you're doing a lot of, and I'm sure we've all been there in parentheses hell before, where you're trying to figure out which parentheses is correct, and you're digging through maybe 4 or 5 levels of parentheses, especially if you're doing functional programming stuff, where you're doing a lot of little functions that compose other functions. Side note, this is actually potentially coming to JavaScript very soon. There is a proposal, I believe, in stage 2 for pipe syntax into JavaScript. So keep your eye on that. We might actually have this syntax in just regular ECMAScript fairly soon. The last thing in the syntax I really want to cover is the module system. To be honest, I feel like the module system is one of the places that feels awkward about Reason, right? In Reason, every file is a module, and every module is global, right? So there is no import statement. You just grab the namespace of your file. So if we had a file called math.re, we would be able to use that anywhere in our app without any import statement, just under the namespace of the file name. So we would be able to do this, math.add, and we could use that anywhere. So you can end up with some weird things as projects grow, because you have to make sure you don't name your files the same thing, which can be a little burdensome. I feel like it actually may force you to, it forces me to actually think about whether I need a new file with the same name, or think about what's actually unique about the files. However, it can be a little awkward if you're coming from JavaScript land. You can actually open a file into a module. So if we were inside another file and we wanted to use math, all over the place, we could actually just open up everything, and we just have that add function as if we had declared it. And then lastly, you can do what's called a local open, basically, where inside of brackets, you could open that module, use it a whole bunch, and it won't bleed up out into the upper scope. This is nice if you are using it a whole bunch in one function, but maybe not much elsewhere. So with all that being said, with the module syntax feeling weird, what this does encourage is you to continually refine your project structure and folder structure. I'm not sure if anyone has experienced this where you move files around in your app and then you spend the next 2 hours, 3 hours fixing your import statements because the search and replace isn't going to work, or it is, and then you're going to screw up more things. Or if you're in TypeScript, it'll try to automatically update your import paths, and sometimes it screws up those. So with having everything being in sort of the global namespace, we actually don't have that problem, at least. However, we do have to, we kind of have a little bit of naming fatigue. So the last thing I wanted to say is there are React bindings. Yes, your thoughts were right. Reason was created by the same guy who created React, and by nature it has first class support. So with that, I'm going to hop over to my editor. We'll do a quick fly through what Reason looks like in React, and to be honest, what React may look like in the very near future. The React team, with the launches of Suspense and other things that they're working on, are largely pulling a lot of things from this Reason React bindings, actually. So let's take a quick look. So I'm going to look at two types. We're going to look at a stateless component and a stateful component, and just what the syntax between those two is. Is that font size good, or should we bump it up?
Maybe over here.
Yeah, and let's actually, I'm going to switch to that's probably a little too big. And I'm actually going to switch to a light screen, just so we can see it. Is that better?
That looks really good.
Okay, cool. So in Reason, like I said, we don't have this, and we don't have classes we can extend. So to create kind of the template for the component, we have to basically say let component equals React and stateless component. So you have to use kind of this function generates a component. This would be the equivalent, if you're familiar with React, of saying class button extends React component, right? It would be the equivalent of this. Kind of gives us the template, all of the life cycles, et cetera, et cetera. Really quick right here, I just added a couple styles. This is kind of from my own way of learning, right? As I kind of build a button, I build a counter, I build a GitHub search. I always do that whenever I'm learning something new, and so that's what this is from. So I'm just going to close this. This is a local module, so that we'll see that we have styles available as kind of like a module, but it doesn't bleed outside of this file. Second, so we defined our component template, and then the second thing that you have to define for Reason React is a make function, right? Which takes each of these named arguments, our props, right, in React, and then the last one would be our children. So, and we spread our template into it. So this does the same thing as, like we said, it extends React component, and we use a render method that gives us, as we scroll over, we see that the JS syntax is pretty close, actually, right? The only difference is that we don't actually have to do the brackets, so we can actually just do this. And if the prop is named the same as the prop that you're passing, so in this case we had an on-click prop, and the button underneath the hood has an on-click prop, we don't have to do any labeling. This is called punning, by the way. I don't know why, but that's what it's called. So that's kind of our basic syntax, and that gives us a React component under the hood. And this is really cool if you're trying to incrementally adopt Reason, is that you can move some components into this, and you can actually consume them on the React side from your JavaScript code. So you can switch some components into Reason, and then you can actually just use them from JavaScript. With that, so we also have a stateful component, which is a little bit weirder, a little bit more unfamiliar to our classic React state, because React stateful components are so object-oriented, class-oriented. This is going to feel very, very different, but I'd encourage you to kind of look at it. So the first thing we have to do is say the type of our state, right? So we have to declare a record, or we have to just declare a type called state. It has to be called state, and that defines the type, the shape of our component state. The second thing that we would have to do is we need to define an action type. So this would be the type of things that we can do, the things that we can do to update our state, right? This is one of those variant types that we were talking about before. So if I wanted to, increment by a number, we could say increment int, and that would allow us later on to pass that as an argument to our state updates. Once again, I just have style, but we declare our component, and it's called a reducer component. If you're familiar with Redux at all, you will recognize the terminology, right? We'll recognize state, action, and reducer. This is Reason's kind of way of handling local state inside of its component is actually the Redux kind of model. And so as we look later on, so we declared our component, we have our make function, and we spread the component in. We create an initial state. This has to be a function, and it has to return the type of state. So if I make a typo, see the compiler says, hey, unbound record field, like, hey, did you mean count? And so, so the compiler's on our side there. And then we actually have this reducer method, which is one-to-one basically the exact same as a Redux like reducer function, where we take an action, we kind of switch on it, and so we say, hey, do I want to increment? Return the count plus 1, right? So take whatever the previous count is, add 1, great. And that'll trigger a new re-render with your updated count, which is super cool. If we want to decrement the counter, we say, hey, is the count 0, right? We're not going into negative numbers on this. So is it 0? Just leave it at 0. You can't do anything past that, or -1 until you hit 0. And so after our reducer, which this looks very much like a Redux reducer, and this is all built into the Reason React bindings. So to be honest, as I've been building apps, I haven't used Redux in a Reason React project yet because it's all built into the component state. And this forces us to kind of do a functional, really easy testable, right, pattern for our components. And then in our render method, right, we would do the same thing, JSX plus inside to actually send those updates. There's a method called self.send. Self is, let me get off of that. Self is Reason's answer to solving this, right? We don't have this, so we have the self. I believe that's also in Python, they do that fairly often. I'm not 100% sure, I don't do a lot of Python, but it's a fairly common pattern. One last thing I did want to say about the JSX syntax, though, is that this is a little weird, right? We have to manually say our text is a string, right? So if I just took this out and said decrement, compiler is going to yell because this isn't an actual DOM node, right? It's just text, and it expects it to be a React DOM node. So the Reason React answer to this is to manually force you to declare everything as a string or as an array or any of those types, because it has to be static typed, and everything has to, everything inside of that JSX has to turn into a DOM node at the end of the day. We do have to manually cast. So it is a little weird. It is a little clunky if you're coming from JavaScript land. It's a small price to pay for true security, that when you pass something in, that it can be cast to a DOM node, right? I'm sure some of us in React projects have put things inside our JSX that weren't capable of becoming DOM nodes, and then you end up with a massive stack trace. So that's about it for the presentation. If we have any questions, we could probably turn on the lights and if we want to just chat a little bit about Reason. If anyone has any questions, we can kind of dive more into the weeds.
I've got a few questions.
Yeah.
For children,
yeah.
I know you talk about the sacrifice. Is there ever a movement to do more of binding children as a prop instead of nested within JSX?
So meaning right here?
I guess.
It's passing children as a prop?
Yeah.
Yeah, so this is actually passing a children to that button component we looked at earlier.
Right, but instead as a JSX attribute.
Oh, I see what you're saying. So like this, right?
I mean, that would ditch the sacrifice, right? You wouldn't have to be so explicit.
You mean like this, right?
You'd still have to be as explicit.
I think you might still have to be as explicit. I haven't tried that, to be honest. We'll see if it yells at us. Best way to find out is to just try it. Looks like it's okay by the compiler, right? So children isn't a named argument. It's just the last argument, so I'm not sure how that's handled under the hood. So if we look at our button, right, it's not, these are named arguments and this one isn't.
Got it.
Right, so I'm not 100% sure whether it's kosher, but the IDE isn't complaining. So, however, you would still have to manually cast it because the children prop is typed as a React element. So.
In terms of back to the list data structure,
yeah,
you were mentioning that you could, you don't have to, it makes an inference in the type when you try to use, it wasn't an enum, what was the reason term for an enum?
Variant.
Variant. You could, it tries to infer variants. If you had a list of variants and they were different, could you explicitly make the type of variant within the list?
I see what you're saying. So if I had, here, I just popped open something different. So here, let's just scroll down a little. So we have like type A equals, and this is A, B, right? And then we have, this is going to be a little weird, but you're saying like if we had type C equals, and that's like, huh?
D and E.
Yeah, right. Like, or we'll do C and D because we can.
Okay.
And you said like, let's add a semicolon. Let list equal, and you said A, C, D. That is one thing I forgot to mention is that the list data structure actually has to be all of the exact same type. So the array can be mixed types, if I remember correctly. Don't fully quote me on that.
Okay.
But the list type definitely does have to be the exact same type all the way through. So if we were, on a smaller scale, right, we can do this with A1, and then C, right? It's going to yell at us.
What about a variant of variance?
Variant of variance. I'm not sure about that. That is one of the weird things right now. Is I don't think you can compose your variants. I haven't dove into it quite yet, but there's this concept called polymorphic variance, which is a huge term, and that's a mouthful, right? Like you basically prepend them with this, but I don't I haven't quite dove into that part of Reason yet about like composing variants together. For most cases, you're usually pretty fine just just duplicating a little bit of code for your variant types to make sure that later on when you change, if you start composing your variants, then you want to change the one at the root. It's the same problem that you end up with it's the same problem you end up with heavy class inheritance, right? Where you can end up, if you need to change the base class, you're in for a whole world of hurt. Yeah.
So just kind of coming back, I guess more higher level bird's eye view. Is Reason supposed to replace anything?
I'm not sure. Yeah, I think so. It kind of sits in the same space as Elm, in my opinion, and Elm, Dart, a lot of these languages that compile into JavaScript. I wouldn't say it necessarily replaces TypeScript because they're kind of too. That's the other big question I've gotten a lot is well, why can't I just use TypeScript? That just gives me types, right?
Yeah.
And as we saw, this doesn't exist in any other language to add a string to our type. Or it exists in a few other languages, but definitely not in TypeScript, is to add arguments to our enums. So I guess it's not going to, I don't know if it's meant to replace anything, but Elm, PureScript, Dart, a lot of those languages that are already statically typed and support JavaScript as compile targets, I think those are kind of the competitors. You could replace a JavaScript code base with Reason as you went along, right? I think that's what Facebook's trying to get it ready for, is to add a layer on top of JavaScript. Yeah.
Jay Phelps at React Rally, remember he's talking about WASM, and he was opining that maybe Facebook might eventually try to get the rest of the world to use ReasonML instead of porting open source to JavaScript. The point being that it's an easier target for WebAssembly. But if that is a future, it's probably a very long-term future.
Yeah, so I guess as we saw earlier, like it does compile to assembly. And so because of that, you can support a lot of different compile targets. So I think they're also trying to sit in that same space where you're looking for the holy grail of languages that compile to everything from one code base. And yeah, so you can, so you can be a native developer, a web developer, embedded systems programmer, and you could be them all in one with one language. I think that's what they're shooting for with this. So yeah.
Does that mean it's going to replace React Native, do you think? Eventually?
Actually, there are bindings in Reason to React Native already. Okay. There's also a library in Reason right now called reprocessing that will, under the hood, depending on your compile target, compile to OpenGL for iOS and Android, or WebGL for web. So you can actually, via that library right now, actually write full, like games. Usually it's an animation library. So you can write games that kind of compile to everything all at once. And people have actually written some games that are truly cross-platform with a single code base. Yeah. So.
Are there any like Git projects that you've been like looking at, that seem pretty awesome? Or
like things in Reason and stuff?
Yeah, using Reason right now.
Yeah, I guess we can do a quick look at that. So definitely the docs are useful. I've been looking at those quite a bit. Actually, I'm not going to open up a new tab. So definitely the docs, definitely BuckleScript. I've been keeping an eye on how those things are progressing. Every day I'm seeing something kind of new pop up. I just saw something the other day that will take a language macro for Reason that will go through your app, pull out all the strings, and give you a localization blob. So just at a language level, right? And says like, when you're compiling, so when you're writing, you don't even think about localizing strings. You don't even think about adding them to your blob and then maintaining that blob. You just write your code, and it goes and pulls all the strings at the end. So that's something I saw recently that was pretty cool. Like I said, reprocessing is pretty cool. I'm looking at that and keeping an eye on that because you can compile to everything at once. So those are two that I'm really, really kind of keeping my eye on right now. Reason React as well, just because it feels like future React under the hood.